What's up, guys? Such a long time. Today, I'm going to show you the fastest way I know to build and deploy and manage a real-time machine learning system. Let's get to it.
Hi guys, this is Pau. Yeah, the same guy who was talking to you like 2 seconds ago. It's the same, okay? It's me. Okay, let's go. Let me show you the GitHub repository that I put together so you understand how to build a real-time ML system on top of the Turbo ML platform. So first of all, let's go. This is the repository. Let me scroll up. Here it is. It's under Paulescu, which is my GitHub username. Don't ask where this thing is coming from. And then end-to-end real-time ML. So here's the repo. Let's clone it. So I'm gonna go here, SSH URL. Here it is. So I'm gonna go to the terminal, git clone. Here it is. Okay, is it there? Yes, cd end-to-end, and then I'm gonna open it with Visual Studio Code. I'm using Visual Studio Code because we are gonna use one very useful development tool called dev containers, which not all IDEs support. Visual Studio Code supports, so this is it. Here we go. Okay, so I'm gonna close this one. Here is the project. Okay, so here's the same README. Now, in order to ease the development, I'm going to use a dev container. What's a dev container? A dev container is like a sandbox environment. It's essentially a Docker container inside of which you have all the development tools that you need while you're developing your project. And dev containers are super useful because they allow developers working with different environments inside the same team to share the same tooling. So instead of me working with my tools inside my MacBook and you, for example, using your Windows tools and each of us setting up all the development environment alone, we're gonna define one common environment, one dev container that both you and me can spin up locally. And for that, you're gonna need first the Docker engine installed in your system. And don't worry if you don't have it, if you go to the README, you're gonna find the instructions. And then inside this dev engine, we're gonna spin up this dev container with all the tools we need to develop for this project. In this case, the dev container, you can find it in devcontainer.json. And here we're building on top the unofficial image that the TurboML has prepared for us. So this is an image that has all the development tools that you're gonna need to locally develop and run your scripts against the TurboML platform. So in order to start using the dev container, you need to open that container. So for that, you can go up here on the lower left corner, you're gonna click and you're gonna click on reopen in container. If you don't see this option, it means that you don't have the dev containers extension installed in your system. And again, don't panic if you don't have it. In the README, you can find instructions to install it. It's super easy. You just add it like a normal VS Code extension. So we reopen in container. Here's it. And now, basically, you can see it saying connecting to dev container. You can check here the logs. And here we are. Now, if you observe here on the lower left corner, it says dev container Python. So now we are running, this thing is connected inside the dev container. How do you know that? Here below on the terminal, if you just check uname A, basically you're gonna see this say Linux, blah, blah, blah. So my MacBook, I'm using a MacBook, but this terminal is actually connected, is SSH into the container where we are developing. And the container is based on Linux. So it doesn't matter if you use Windows, MacBook, we all use the same environment. Long life dev containers. Long life or long live? God bless dev containers. Okay, so now how do we build our system? Our system is composed of a feature pipeline, which is responsible to transform this incoming transaction data into features. Then the modeling step, so we're gonna need to define what kind of model we want to use. And then we're going to generate live data to check that the whole system is working. So the three commands, you can find them super simplified in this make file. So in this make file, I created three commands you can run. So you can define your feature pipeline with make feature pipeline. With make model, you're gonna set up the model and push this model definition to TurboML. And with make live data, we're going to simulate actual production data being generated and being ingested into the TurboML platform so that we can check that the model works. So before doing that, you will need to get a free account at TurboML. So you can get a free account, you can play with it for 24 hours. And then if that's not enough for you, you just sign up again and you're gonna get 24 more hours. So you can play an experiment for free. For that, super simple. Let's go to TurboML. So here it is. Let me start. So you go to TurboML and then you go try now. You need to log in. So I'm gonna use my Google credentials. And here we are. So here I'm inside my TurboML dashboard. So to start to communicate with the TurboML platform, we're gonna use the Python SDK, TurboML's Python SDK. In order to authenticate and use it, we need to get two important parameters, which are secrets. Don't share them with anyone. The backend URL and the API key. So these two parameters, you will find in the repo I created a .m example. So you just need to copy this thing and rename it as .m. And then here, you need to copy these two parameters. So the backend URL is here. Let me copy it here. So backend URL. Let me increase here the size so that you don't end up going to the ophthalmologist after this video. And here is the API key. So here we are. Super. So now in terms of authentication, everything should be good to go. So now let's first define our feature pipeline. For that, I created the make setup feature pipeline, and to run it, it's super simple. You just do make feature pipeline. And now this thing, while this thing is running, let me show you the inners of this Python script. So to define the feature pipeline, this follows like a declarative approach, meaning that you define the transformation logic, and then you say TurboML, you send it to the TurboML platform, and then you let TurboML handle all the low-level details necessary to bring this logic into life. And why is that important? In real-time ML, performing transformations, doing transformations in real time requires at least two important pieces of infrastructure. One of them is a message bus, typically a Kafka, Red Panda, whatever, that basically moves data asynchronously in real time between services. And this is basically the data transport. Now, this element, Apache Kafka, helps you move the data. But to do feature engineering, you need to, apart from moving data, you need to transform it on the fly. And this is when a real-time data processing engine enters into the game, which means that you also need to add something like Apache Flink, Apache Spark streaming. Also, there are Python options, but in any way, you need to bring not so easy to handle pieces of infrastructure to bring your logic to life. And this is what TurboML does for you out of the box. You define your feature engineering logic using Python, you submit it to the platform, and you're done. From that moment, TurboML takes care of executing, so spinning up the necessary resources to compute these features in real time as new data comes into the platform. So in terms of feature engineering, in this case, I just created one feature, which is it's called a window feature. So based on all the transactions, so whenever a new transaction enters into the ML platform, one feature that might make a lot of sense for me to compute is how much money was spent using that card in the last 24 hours. So this is one example of a window feature, and they are very common in real-time ML systems, right? So this is called stateful calculations. They're not so easy to implement, they're not so easy to handle at scale, but this is something that you don't need to worry here. You just define the logic, and then TurboML will bring in the necessary resources for this thing to actually happen fast enough for your use case. So in this case, we're using the Python SDK that TurboML has. It's super easy to use, and if I scroll down, I'll see that yes, the features have been already created. So now if you go to the dashboard, if you go to features, you will see that there are two feature groups. We have one for the labels. The labels are binary numbers, 0 or 1. 0 meaning the transaction is non-fraudulent, 1 means the transaction is fraudulent. And then here, the other feature group are the features, which means all the information we get from a transaction, plus the features that we engineer on top of it. So in this case, we have the transaction timestamp, the origin, several more raw features, plus the one that I engineered here, which is the total amount spent with this card in the last 24 hours. So this is our feature pipeline. It's there and it works. So now you can move to the next step, right? You have the features in your feature store inside TurboML. Now you want to start creating some predictive model. So you want to use them to try to find correlations between the features and the labels, right? And this is the part where we move to the second pipeline of the system, which I call setup model. Call it setup model because we're not really training inside our computer. Here we are leveraging the TurboML platform. How? What we're doing is we are defining how we want our model to work, meaning what are the input features and the labels we want the model to output, the model type, which in this case I'm using a Hovding tree classifier. This is a very standard real-time online ML algorithm. There are many of them you can play with. You can use out-of-the-box algorithms provided by the TurboML platform, or you can create yours, for example, using a Python library, an open source one called River. Then you define, as I said, what are the features, divide to numerical or categorical, and that's important because this way you tell the model what features, what columns need to be encoded so that they can be used. And that's it. And you push the model to the platform, right? So when we run this script, which is what I'm going to do in a second, we're going to submit this model definition to TurboML. And TurboML will use all the data we pushed so far regarding previous transactions to train an initial version of this model and deploy it. And that's not the end of the story. Why? Because some real-world machine learning problems require what is called online retraining, and fraud detection is one of them. Fraudsters are constantly trying new strategies, new ways to try to commit fraud, right, and use money illegally. So if you build a machine learning system that is supposed to predict fraud, you need your machine learning model to continuously adjust to new fraud patterns that you are able to detect. And for that, you need to have a system that continuously and incrementally adjusts your model so that it doesn't get old. This is something that is not easy to implement in practice, it's not easy to monitor, it's not easy to diagnose when things go wrong, so it's something that you would typically spend a lot of time doing it on your own. And this is when TurboML comes into the game again. So with TurboML, we've pushed the model is trained with the initial historical batch of data, and then TurboML takes care of updating incrementally and versioning the model. And that's super important because if at some point you check the monitoring metrics and things do not work well, you can always roll back, right? So this process of online retraining and model versioning is something that TurboML brings here, and it's super, super useful for this problem. Okay, enough talking. Let me try to run this thing up. So let's do make model, I think I call it. Let me check, yes. Make model. Here it is. So you know what happened here? I already deployed this model before, so I cannot really deploy with the exact same name, but that is fine. Then I'm just gonna check the model that is there. Let me go there, models. Here it is, super, here's the model, super. Okay, so now the last thing that I want us to do, let's generate some actual data and check that the whole thing is working. So for that, in general, in a real world setting, what you would do is you would connect TurboML to your data source, which can be an S3 bucket, can be your internal Kafka topic, whatever. To simplify things here, I'm just going to manually send data to the TurboML platform. And I'm going to do that by simply taking historical data and resampling it. Okay? This is a very common way to basically perform integration tests and test that your system actually works. So for that, in the make file, I have make live data and this script, which is doing this sampling and pushing data into TurboML. So let me clear this thing and let's do make live data. Okay, I see transactions being pushed into the TurboML platform. I mean, a lot of them. I mean, this script is like a long running job, so it's gonna run for ages. But the point here is that we are pushing data into the TurboML platform. So now what I want to see here is first, is the model generating predictions? and also how good they are. So for that, let me go to the dashboard, and if you check on models, here's the model, it's under status running. Super. Now, if you check outputs, here it is. Super. So this thing is actually scoring data. And then something that is very important that I said, versioning. So any model that is pushed into a platform needs to be updated continuously. This is not a hard requirement. This depends on your problem. But for example, for fraud detection, that's a must. So you need to think about how necessary that thing is for your problem, how relevant, how important is the online incremental training here. And if it is, then it's the easiest way to implement it. So for example, this is a model that I already pushed. So here you can see the model versions. You can see the first version that I pushed 1 hour ago, and then that it's been updated and versioned. So here you see the model version. So if something is not good, you can always roll back. So this is the part where TurboML does the heavy lifting, implements online retraining to your model and model versioning so that you can actually diagnose. So if something does not look well in terms of monitoring, so in the outputs, in the metric section, sorry, here it is. You can always fetch the exact model given the version and then do some kind of analysis to understand. Okay, so adding incremental retraining is something that you can do step by step, and you can do with safety using TurboML. So this is a very, very powerful tool. Now finally, what else did I wanted to show you? So here's the README. Also model monitoring and model comparison. Yes, that's also a very, let's say, real world problem, right? What we did here is that I show you how to create your first model, push it to the platform and see that it works in terms of is it scoring data and what are the error metrics. Now, 2 weeks later, it might happen that you got new features, you got new data that you want to use to create a second version of the model. And the thing is that you don't want to break what's running in production. So the safest way for you to do that is to keep the current model running and then deploy a second model and keep both models scoring in parallel for a certain amount of time so that you can compare predictions. Model A, so the current model you have in production, versus model B, the model that you just developed and you are testing if it's better than the one you already had. So with model comparison is something you can do super simple. When you show the metrics, you can compare models here. So if you have a second model, you can compare it and you can see errors, one next to the other. And if things look good, means that you are ready to promote this model that is in the development stage. You can promote it to the production stage. So model comparison, something very useful, very day-to-day operations that you need to do well once you have a system running in production. So that's it. Everything that I talked, everything is on the GitHub repo. And if you didn't understand, because my English is too Spanish for you, which I understand, I mean, my wife tells me that, don't worry. You can read it yourself in the README, okay? So now I'm gonna go back to where I was and then
now it's your turn. Sign up for free at turboml.com and start building your own real-time machine learning system. You can either improve the one that I provided, make it better with feature engineering, with hyperparameter tuning, etc., or build your own real-time ML system for the problem that you care about. And if you want to get more hands-on content on real-world, no bullshit, machine learning, subscribe for free to the Real World Machine Learning newsletter every Saturday morning for free. Did I say for free again? I'm so boring. Did I say that? Okay. See you soon.